Make sure the compound slide is all the way forward. Place the parting or grooving tool into the tool post and square it with one of the chuck jaws. Tighten the tool post in place, ensuring it stays square. If you're turning between centers, place the lathe dog on the part. Turning between centers enables more precision than when a part is simply clamped in a chuck. Place the part between centers. Move the live center toward the part until there is enough friction to move the live center while moving the part. Lock the tailstock sleeve in place and zero the grooving tool to the end of your part. We slide a piece of paper between the stock and cutting tool until it is pinched slightly. Measure the thickness of the paper and enter it in the DRO. The thickness of the cutting tool must be accounted for when making the first grooves. We moved to -2.130 since the width of the grooving tool was 1/8 of an inch. Adjust the RPM to a reasonable speed and zero the x-axis. Once you see a chip fly, enter the diameter of the part into the DRO. Apply plenty of cutting fluid while grooving to 40 to 50 thousandths from the smallest diameter of the part. Move the grooving tool and cut another groove. Keep making grooves into your part until there is enough room for the right to left cutting tool. Take out the grooving tool and place a right to left cutting tool into the tool post. Ensure only the tip of the cutting tool is in contact with your part and zero the z-axis using the same process as before. Once again, take the thickness of the paper into account. Now zero the x-axis by using the skim touch-off method and enter the diameter into the DRO. Begin turning down the diameter, stopping at about 15 thousandths from the desired length being turned down. The largest diameter being turned to is 3/4 of an inch. To allow for a later finish pass, leave 5 to 15 thousandths. To get a better surface finish, use the power feed on your lathe. After nearly turning to the desired dimension, double check the diameter of your part with a caliper or micrometer. Adjust the DRO if there's any discrepancy. Next, turn down the middle portion of the dog bone part. Once again, leave extra material to later finish the face of the step at -4 inches. Make a finish pass at 1/2 inch. Then finish the face of the step at -4 inches. Turn the diameter of the next step down to 3/4 of an inch. And finally face the edge of the step at -5 inches. Replace the right to left cutting tool with the left to right cutting tool. Use a piece of paper to zero the z-axis. Measure the distance between the arrows and add the thickness of the paper. Enter that value with a negative sign since your zero is in the positive direction toward the live center. Don't forget to zero the x-axis as well. Turn the step down as done before. It isn't a bad idea to double check the diameter with a caliper before making the last pass at 3/4 of an inch. Remember to leave material to enable a finishing facing pass at -1 inch. Continue by turning to the 1/2 inch dimension. On the final pass, engage the power feed, and while the cutting tool is moving toward the live center, move the cutting tool toward the 1/2 inch diameter. Using this technique will leave a smooth transition line between the right to left and left to right cutting tools. Finish the part by facing the step at -2 inches. Double check the diameters of the part with a caliper or micrometer. Remove the part and measure the length. When clamping the part in the chuck, place the jaws on the turn portion to ensure concentricity. Don't push the step tight to the jaws for the same reason. Replace the left to right cutting tool with the right to left one. Touch off the part, enter the measured dimension into the DRO, and cut the part to the desired length. Here are some important things to remember. Ask questions if you need help. Don't force the live center into the part. If this is done, the bearing will heat up and ruin the live center or possibly even start a fire. Always zero each cutting tool. They are not the same size and are not placed in the tool holder the exact same way either. Make sure you're always cutting with the tip of the cutting tools. If you can't get the proper tool clearance because of obstructions, use alternative or custom tooling to ensure proper tool geometry.